Right now, a computer chip called an Nvidia H100 is flying over your head. It is the same kind of chip companies use to build AI. It went up on November 2nd, 2025, inside a satellite about the size of a refrigerator. The satellite weighs 60 kilograms and circles about 325 kilometers up, on a path around Earth where it almost always sits in sunlight. No other chip like it has ever worked in space before. Not one. In December, that satellite did something with the chip. It trained a tiny AI called Nano GPT, the kind students use to learn how AI works, by having it read through all of Shakespeare's writing. It also ran a separate, smaller Google AI called Gemma, and had it answer questions like a chatbot. CNBC said it was the first time anyone has ever trained an AI outside of Earth. That already happened months ago. The company that did it is called Starcloud, and almost every news story about Starcloud says the same two words: Nvidia backed. Those two words are doing a lot of work they should not be doing. Here is where Starcloud's money actually came from. Two investment firms, Benchmark and EQT Ventures, led a group that put $170 million into the company. After that, people valued the whole company at $1.1 billion. That happened about 17 months after Starcloud was showing its idea to a small startup school. None of that money came from Nvidia. So what does Starcloud actually get from Nvidia? Two things. It is a member of a free club Nvidia runs for small startups, and it buys Nvidia's chips. Buys. Nvidia sold them the chips. Selling something to someone is not the same as owning part of them. If you buy a bike from a store, the store does not own your bike. Nvidia sells Starcloud chips and lends Starcloud its name. It does not own a piece of the company. One more mix-up worth fixing. On January 11th, 2026, two more space computers went into orbit. A lot of news stories said they were Starclouds. They were not. They belonged to a different company called Axiom Space, and they talked to Earth using a network built by another company called Kepler. Starcloud's own second satellite with more chips on board goes up later on its own trip. Now here's what Starcloud promises. Starcloud says putting computers in space makes the power about 10 times cheaper than running them here on the ground. Two reasons. Up there, the sun almost never goes down, so you get free power. And space is freezing, so the heat leaves on its own and you do not need giant air conditioners. That sounds great. So I went and read what other engineers said about that math. Two of them checked it, a review by a site called Blocks and Files, and a separate check by an engineer named Angad Nanjangud. Both found the same hole. Starcloud counted all the money it saves on power, and barely counted the money it costs to get everything up there in the first place. Rockets are expensive. Starcloud's math assumed it costs about $30 to send 1 kilogram into space. Real prices today are $500 to $1,000. Then there's the heat problem. In space, there is no air, so you cannot use a fan to blow heat away. You need big metal panels to push the heat out instead. To cool a real working system, you would need panels covering 63,183 square meters. That is about 9 soccer fields floating in orbit. You cannot fit 9 soccer fields inside one rocket. That works out to somewhere between 17 and 22 separate rocket launches, not one. So here are the two answers. Starcloud's own numbers say the whole thing costs about $8.2 million. The engineers who checked say it costs somewhere between $1.7 and $2.2 billion. Same computers, same orbit. The only difference is who counted the rockets. 10 times cheaper is the number Starcloud itself came up with. Barely cheaper at all is the other number. I am not going to put 10 times cheaper on the screen like everybody agrees on it, because they do not. I am telling the story in a certain order on purpose, and I would rather say that out loud than pretend it just happened that way. Starcloud goes first because it is the one with the most proof. Its hardware is up there. Its AI training already happened. There is no maybe in any of that. Lonestar flew before Starcloud ever launched, twice, all the way to the moon. That much actually happened. But its biggest claim about what happened up there is still only the company's own word. Nobody outside Lonestar has checked it. Last is a company that has not launched a single satellite yet, and is promising the biggest version of all of this. By the end of this video, you will know exactly which of the three has real working hardware in space today, and which one is still a very well-funded idea. There is a data center sitting on the moon. It is lying on its side in a crater near the moon's south pole where sunlight never reaches. It is inside a lander named Athena. Athena tipped over in February 2025, and its battery died in less than 13 hours. The company that built the data center is called Lonestar. Lonestar says its little computer kept working the entire time the lander still had power, moving files back and forth, checking who was allowed to open them on the moon. Lonestar says that is the company's own story, told afterward. Nobody outside the company has confirmed it. The lander broke. That part is confirmed. The computer inside it, according to Lonestar, kept working the whole time. That part is the company's claim. Mix those two up and you have told a story that is not true. This was not even Lonestar's first moon trip. A year earlier, in February 2024, it sent up a different computer named Independence on a different mission, inside a different lander named Odysseus. Odysseus caught a leg on landing and tipped onto its side too. The same kind of stumble Athena would take a year later, except Odysseus tipped over out in the sunlight and just kept right on working. From the surface, Independence sent the Declaration of Independence to the moon and got the Constitution and the Bill of Rights sent back on behalf of the state of Florida. Keep these two names straight in your head. Independence wrote Odysseus in 2024. Freedom wrote Athena in 2025. Swap those and you are talking about a completely different story. So why put a computer on the moon at all? Lonestar's boss, Chris Stott, gives the same answer every time he's asked. He says space protects data from, quote, climate change, natural disasters, human error, wars, nation states going after immutable data. Translated into normal words, if all your backups sit inside one country, then a flood, a war, or a government order can reach them. Put a copy somewhere no government on Earth can physically walk up to, and that problem goes away. That is his sales pitch, not a neutral fact. He is also trying to sell 6 more of these satellites. You are probably already asking the obvious question. How do you run a computer where there is no air and nobody around to fix it when a part breaks? The no air part actually helps. Heat normally moves by warming the air around it, and there is no air, so instead these computers push their heat straight out into the cold. That works fine, as long as you built the right panels for it. Nobody is up there to fix a broken part, so these computers are not built to be repaired at all. If a piece breaks, it just keeps running on whatever still works. It gets a little worse instead of shutting down completely. Lonestar's computer weighs about 1 kilogram. It holds 8 terabytes, which is a few thousand movies, and it runs on one small chip made by a company called Microchip. Here is something Lonestar is not doing. It is not training AI. The company's president, Steve Eisele, has said it plainly. These satellites are for storing files and doing small jobs nearby, not for the heavy AI work the other 2 companies in this story want to do. People use the words data center in space for 3 totally different businesses. Lonestar is building a safe deposit box. The other 2 are trying to run AI up there. Do not let anyone smoosh those together for you. Lonestar is not stopping at 2 flights either. It has an early agreement with a company called Sidus Space, worth around $120 million for 6 more satellites. In December 2025, Stott described all 6 going up sometime between 2027 and 2030. The first one, called Starvault 1, is supposed to hold 15 petabytes, and each satellite after it roughly doubles that. That first one now has a closer date. In April 2026, Sidus Space said Starvault 1 would go up no earlier than the fall of 2026. That is a firmer date for 1 satellite, not a new schedule for all 6. None of them have flown yet. And even when they do fly, there is one problem no company can talk its way out of. Physics. A message takes about 1.4 seconds to travel from Earth to the moon, and the same amount of time coming back. That is too slow for anything that has to happen right this second. Nobody is going to stream a movie off a hard drive on the moon. This is a mailbox, not a phone call. Which brings us to the company that has not launched anything at all. On November 4th and 5th, 2025, Google's boss Sundar Pichai announced something called Project Suncatcher on the social media site X. The plan is solar-powered satellites carrying Google's own AI chips, which Google calls TPUs. Elon Musk replied the next day on X, quote, "Great idea, LOL." Pichai wrote back, quote, "Only possible because of SpaceX's massive advances in launch technology. 2 competitors agreeing with each other in public where everyone can see it. That tells you how normal this idea has become. But Google has not launched. As I am recording this, the number of Suncatcher satellites in orbit is 0. The plan is 2 test satellites, built with a company called Planet Labs, aiming for early 2027. The research paper behind the announcement imagines something much bigger than 2. It describes up to 81 satellites flying together in a group about a kilometer wide, some of them only 100 to 200 meters apart. They would talk to each other using beams of light instead of radio. Those beams moved 800 gigabits every second in each direction, 1.6 trillion bits a second total in a lab test. That is a picture in a paper, not a build order. One thing Google has actually tested is whether the chips can survive space. Space is full of tiny particles that fly through electronics and break them over time. So Google fired a beam of those particles at its chips on purpose, at a strength far past anything they would meet in orbit. Nothing broke permanently, all the way up to the strongest dose they tried, which was about 20 times more than the chips should soak up in 5 years up there. The memory did start acting strange, but only at almost 3 times that 5-year amount, all measured before a single one of these satellites has left the ground. There is a catch with flying satellites that close together though. Google's own paper says the tight spacing is on purpose, not a mistake. Packing them close is exactly what lets those light beams tie all 81 satellites together into one big computer, instead of 81 separate ones passing notes. But a researcher at the University of Michigan named Mujtaba has a warning. Neighbors 200 meters apart in an orbit that is already crowded with other people's satellites is a real crash risk. For comparison, SpaceX's Starlink satellites had to move out of the way of something over 144,000 times in 6 months, and those are nowhere near as close together as this. Putting 81 satellites in a bunch the size of a small town and assuming nothing goes wrong is the kind of thing that looks fine on paper. It gets tested for real the first time 2 of them start drifting toward each other. So, the question I asked at the start, which of these 3 is actually furthest along? Starcloud has a chip running and an AI already trained in orbit today. No asterisk needed. Lonestar has already flown 4 missions, 2 of them all the way to the moon. A 5th is aiming for this fall. Google, for all the ambition in that paper, has not put up a single satellite yet, with its first 2 still hoping for early 2027. Sort them by what has actually flown instead of what has been announced, and this stops being one big idea. It turns into 3 different bets on 3 different timelines from companies all counting on nobody reading the small print as closely as I just did.